see the next chapter called complex numbers. It is second chapter, complex numbers. Under this heading, we are going to see all these things. First one is let us say what is the definition of a complex number and basic algebraic properties of a complex number. After that, we are going to see conjugate and modulus and their properties. We are going to see their locus of a complex number. The next one is polar and Euler form of complex number. That last we are going to see De Moivre's theorem and roots of a complex number. These are the things we are going to see under this heading. Now let us see one by one. What is a complex number? Let us see what is an imaginary number. Okay, for that let us consider these two quadratic equations, x square minus 25 equal to 0 and the other one is x square plus 25 equal to 0. Now we know how to solve these two quadratic equations. This can be solved as x square is equal to 25 means x is equal to plus or minus root of 25. Then you can say x is equal to plus or minus root of this 25 is 5. Therefore, the roots are x is equal to 5 or x is equal to minus 5. Now, since it is a quadratic equation and has degree 2, therefore, it has two solutions, that is x equal to plus 5 and x equal to minus 5 are the two solutions of this equation. How we are finding the solution means here, if you square this 5, you will be getting 25. Similarly, if you square this minus 5, you will be getting plus 25. Therefore, while squaring either a positive real number or a negative real number, definitely you will be getting the positive number. Therefore, if you square any real number, definitely its square will be a positive real number. Now, let us see this one. X square plus 25 equal to 0 means you can say x square is equal to minus 25. Then x is equal to plus or minus root of minus 25. Now, here the question is whether we have square root for this minus 25 means now we can say no, because we cannot get the square root for the negative numbers. Based on this concept, if we square any one of these two numbers, definitely getting a positive number. Therefore, the square of any real number never be a negative number. Hence, we cannot get the roots of the square root of this minus 25 as a real number. Now, there is a root for this negative number that we can call it as imaginary root. For that, see here, whenever you want to find the square root for a number, within the square root you must have a positive number. Now, how do you convert this minus 25 as plus 25 means you can write plus or minus root of 25 into minus 1. Now, we made this minus 25 as plus 25 and we have written minus 1. Now, this is a positive quantity. Whenever you take square root, you must have only positive quantity. For that, they have introduced the concept I square is equal to minus 1. I square is equal to minus 1 means, see, you are replacing this 25 into this minus 1 we are replacing as I square. We can say I square. Now, it is equal to plus or minus square root of 25 is 5. Then square root of I square is I. Now we can get x equal to plus or minus 5y, or the roots are x is equal to plus 5y or x is equal to minus 5y. Likewise, if you square this plus 5y or this minus 5y, you will be getting this minus 25. For example, if you square this 5y based on this concept, 5i whole square is equal to 5 square into I square. 5 square is how much? 25. And I square is minus 1. Therefore, you are getting minus 25. Likewise, if you take minus 5 also, if you put this minus 5 whole square means minus 5 whole square into I square. Minus 5 whole square equal to 25 into I square means you are getting minus 25. Therefore, this plus 5y or minus 5y are the roots of this square root of this negative number minus 25. Now, Now here writing a plus or minus 5i. What is this I stands for? I denotes as, I says as, this plus or minus 5i is the imaginary root for this number. Therefore here I stands for imaginary root. This is ax square plus bx plus c equal to 0. How do you find the nature of the roots of this quadratic equation? See, for that you use the discriminator delta equal to b square minus 4ac. Now after finding this value of delta, if delta is a positive number, we can say roots are real and unequal. Suppose this delta value equal to 0, you can say roots are real and equal. Then suppose this delta value is less than 0, you can say roots are unreal, or you are called as imaginary. If it is not real, we can call this as imaginary. Now that is if delta value is greater than or equal to 0. This one, delta value is greater than or equal to 0, we can say roots are real. If the delta value is less than 0, we can say roots are unreal, or we can call it as imaginary. Now the first letter of the word imaginary I, we are considering as the imaginary unit for finding the imaginary number, for the square root of negative numbers. For that, see, already we have taken the formula. How do you find the roots of this equation? X equal to minus b plus or minus root of b square minus 4ac by 2a. Now based on this formula only, we are going to find out the roots of the equation. But here this delta equal to b square minus 4ac is used to describe the nature of the roots. Therefore here this b square minus 4ac is coming inside the root, that is root of delta, you can say. Therefore if you have this root, this delta is positive, we can get a real roots. Suppose this delta like this minus 25, negative number, delta is negative number, means you cannot get a real roots, you will be getting only imaginary roots. That's why we are using this letter I to denote the imaginary roots. Okay, now let us see. Now here we are getting x equal to plus or 5 means we can say this plus or minus 5 are the imaginary roots of this minus 25, because if it is a plus 25, you can get the square root as real numbers. But if it is negative, that is minus 25 means square root of a negative number definitely will be an imaginary number. Therefore any number of the form 5i or 6i, any real number acting as coefficient of this imaginary root I is called an imaginary number. For example, you can take a bi, or you can take 2i minus I plus 7i. These are called the imaginary numbers, whereas this b is a coefficient of I, and this 2 is a coefficient of I, minus 1 is a coefficient of I, plus 7 is a coefficient. These coefficients are real numbers, Now this I is called imaginary unit. This I is called imaginary unit with the property that already we have seen I square is equal to minus 1 means I is equal to root of minus 1, we can say I equal to root of minus 1, we can say. Okay, this minus 1 root of minus 1 is the positive square root of I. We know very well. Suppose you have x is equal to root of 25 means this value equal to either plus or minus 5 or only plus 5, which is correct. Can you guess? Or both are correct? Here if you are saying plus or minus 5 means that this is wrong. Only plus 5 is the right answer for the square root of 25, because before the square root we don't have any sign, means we are assuming that this is the positive square root. Plus 25 means positive square root. Suppose I am writing 5, this is plus 5. For that you did not mention before that plus, not necessary. Likewise, if you are writing square root of 25 means before that you don't have any symbol, either positive or negative. It means always only positive square root. Therefore, you can take positive square root of 25 will be 5. Suppose you have minus square root of 25 means we can write minus 5 because this is negative square root. This you must keep in mind. This is the difference between square root and a positive square root and a negative square root. Now, let us see some important facts about this powers of interesting facts about the powers of 5. Now, listen here. We can take I power 1 is equal to I only. You can already we have taken this I square as minus 1. I square equal to minus 1. Then how do you find the value of I cube? This I cube can be written as I square into I, because these are the two known values. Based on these two values, you can evaluate the value of I cube. Now this can is I square into I, now which is equal to I square equal to minus 1 into I, which is equal to minus I, we can say. Now if you want to see I power 4 means this is I square into I square, we can write. Now the value of I square is minus 1 into minus 1 is equal to plus 1 we got. Now we got this I power 1, I power 2, I power 3, I power 4. Now let us continue with the other powers. There is I power 5. This how do you write? I power 4 into I, we can say. This I power 4 value is 1 into I is equal to I only. Now suppose you take I power 6. This can be done as I power 4 into I square. Now this will be equal to I power 4 is 1 into I square is minus 1. Therefore, which is equal to minus 1. Now, if you see I power 7 is equal to I power 4 into I cube, which is equal to I power 4 is 1 into I cube is minus I, which is equal to minus I. Now, I power 8 is equal to I power 4 into I power 4, which is equal to 1 into 1, which is equal to 1. Like this, you can find I power 9, I power 10, go on. But look at the interesting fact here. I square is equal to I. So I equal to I square is equal to minus 1. Then I cube equal to minus I power 4 equal to 1. Now look at these four values. Only these four values are repeating. See here. I power 5, you are getting I, that already we have here. Then I power 6, you are getting minus 1, that already we have here. Then I power 7 equal to minus I, that also we have here. Then I power 8 is equal to plus 1, that we have here. Therefore, only these four values are I, minus 1, minus I, plus 1. Only these four values are repeatedly occurring whatever be the power of this I. Therefore, for different powers, you can get only these four results. That is I, minus 1, minus I or plus 1. Now, again let us see some more facts. Only four values for different powers of I. Whatever be the power of I, you can get only these values plus I, minus 1, then minus I, plus 1. Now, when did you get this plus 1? I power 4 we got as plus 1 and I power 8 also we got a plus 1. Therefore, the power of I is a multiple of 4 or the power of I is divisible by 4. Definitely this answer will be 1. For example, see here I power 16. I power 16. This how do you write? I power 4 into 4 we can say. Now which is equal to I power 4 whole power 4 we can say. This I power 4 is 1, power 4 is equal to 1 only. Therefore, if the power of I is a multiple of 4, definitely this value equal to 1. Already we have seen I power 4 is equal to 1. I power 8 is equal to 1. Then I power 12 is equal to 1. Likewise, we can find out. Okay, now based on this, we can write now, therefore, here we can say I power n. N may be any number. Want whether we don't know, it is divisible by 4 or not, or it is a multiple of 4 or we don't know. Now, how do you write this one is we can use the division algorithm. Whatever be the power of I, you divide it by 4. While dividing this n by 4, you are getting some quotient and some remainder. this remainder must be less than this divisor, means R value must be 0 or 1 or 2 or 3. The remainder must be less than this divisor. Therefore, whatever be the number, if you divide that by 4, you will be getting remainder as 0, 1 or 2 or 3. Now, therefore, this n can be written as by using division algorithm 4q plus r we can say. Therefore, here you can write I power 4q plus r. Now you can write this as I power 4q into I power r. Now here you can write I power 4 whole power q into I power r we can say. Now which is equal to I power 4 value is 1 whole power q into I power r you can say. This I power 1 power q, 1 power any number is 1, therefore you can write 1 into I power r which is equal to I power r. Now we can write this I power n as I power r. This r is nothing but the remainder on dividing this n by this 4. Therefore, this I power n can be written as I power r. Now for our convenience, I am writing this as I power n as equal to I power r. Let me write. What is this? Instead of small r, I have written this I power n can be as I power r, which gives I power. Suppose the remainder may be either 0 or 1 or 2 or 3. Now based on let us say I power remainder is 0 means I power 0 is value equal to 1. Then suppose this I power remainder is 1 means I power 1 is equal to I we can say. Then next I square, that is remainder is 2 means you can say I power 2. We know whether I power 2 I square equal to minus 1. Then the last one is I remainder is 3 means I cube is equal to we can say I cube equal to minus I already we have seen. Again say here 1 minus 1 I minus I. Only these 4 values will be repeating whatever be the power of n. Therefore, suppose you want to find out the value of I power 19. I power 19 means how do you write the value of this I power 9? For that you will not write into I power 4 into I power 4 like that. Just you divide this 19 by 4. 4 times you will get 16, the remainder is 3. Therefore, I power 19 can be written as I power 3. You know where I power 3 value equal to minus I. Likewise, you can easily find out. Therefore, this is very important concept for the powers of I. Now, after that, let us see what is this value. So, far you have seen I power 1, I power 2, I power 3, I power 4. Now, let us see what is the value of 1 by I. What's the value of 1 by I? I equal to I only we have written. 1 by I, how do you write? Whatever be this I, with the denominator, try to bring any one of these powers. There is I square you can take. You multiply and divide by I. Multiply and divide by I. Then you will be getting 1 into I equal to I by I square. I square equal to I by I square value minus 1, which is equal to minus I. Therefore, we can say 1 by I is equal to minus I. 1 by I is equal to minus I. And hence, we can write 1 by minus I. What is 1 by minus I? See, this is plus 1 by I. This is minus 1 by I. Minus 1 gives plus I. Therefore, 1 by I equal to minus I. Then 1 by minus I equal to plus I. These things also you must keep in mind. Then only we can do the problems very easily. And also, see, if the powers of I are consecutive numbers, then what will be this value? See here, I power n plus I power n plus 1 plus I power n plus 2 plus I power n plus 3 equal to what is its value. See here we have 4 terms that we are adding. Then look at the powers of I. This is n plus 1, this is n plus 2, this is n plus 4. These powers are the consecutive integers. They are the consecutive. That is, if you have 4 consecutive integers as the powers of I, then while adding these values, you will be getting the result as 0. Therefore, you not see the whatever be the value of n. Suppose you can take I power 19 plus I power 20 plus I power 21 plus I power 22. Now these are the 4 terms, and look at their powers are the 4 consecutive integers 19, 20, 21, 22. If the powers are the consecutive integers for the 4 terms, then result will be always 0, that you need not calculate. Then how do you check? See, already I told I power 19 you can write as in the previous case. If you divide 19 by 4, then 4 times 16 remainder is 3. Therefore, this can run as I cube. Then I power 20. 20 is a multiple of 4. Its remainder will be 0. Then plus I power 1, you can, if you divide 21 by 4, remainder will be 1. Then plus I power, if you divide 22, the remainder will be 2, I square. Now, how do you find this? I cube value equal to minus I. This I power 0 is 1. This is plus I. Then this is I square is minus 1. Look at these two things. Minus I plus I getting cancelled. Plus 1 minus 1 is also getting cancelled. Therefore, its value will be equal to 0. Therefore, if you have sum of i's whose powers are the 4 consecutive integers, definitely result will be 0. Now likewise you can easily find out. Now let us see the exercise problems. See, this is the first problem of exercise 1.1 given at the page number 54. Simplify. Under this heading you are given 6 subdivisions. Now I have done only 4 subdivisions. Let us discuss now, then we can go for the other subdivisions. See here, I power 1947 plus I power 1990. Now you may think the power of I is a very large number, therefore it is very difficult to find its value. Don't think like that, it is very easy. How do you find this value? That is 1947. 1947. Now you have to divide this by 4 and you have to write the remainder only. Then how do you find the remainder? Means see, if the number is divisible by 4, therefore whatever be the number of digits, this is 4 digit number or 5 digit or 10 digit, whatever be the number of digits, want to divide only the last 2 digits by 4, that's enough. You need not divide 1947, just you take 47, you divide it by 4, means 11 times you can get the 44, then the remainder is 3. Just that's enough. You need not divide 1947, just to take the last 2 digits and divide by 4, the remainder is 3. Therefore, this value I power 1947 can be written as I cube. Then plus I power 1990 we have. Therefore, just to consider the last 2 digit 90. Your 90 divided by 4 means we can write 2 times 8 balance 1 0. Again 2 times 8 balance 2. The remainder is 2. Therefore, you can write it as I square. That's enough. Now we made this large power as a very simple power. Now which is equal to, we know very well, I cube value is minus I square value is minus 1. Now this is the value of this expression, minus I minus an r. This can be written as minus of 1 plus I, you can write. Similarly, how do you find this I power 1948? I power 1948 minus I power 1869. Again, just you have to divide the last 2 digits. is equal to I power 48 is divisible by 4. That is, you can divide 48 by 4 means that is 1 time. Then you can write 0. Then you can 8 means 2 times. But you can divide 48. Sorry, 4 to 48 you can say. Now here this remainder is 0 means if the number is divisible by 4, it is a multiple of 4, definitely its value will be 1. Or you can then say I power 0, nothing wrong. Now here minus I power 1969. You divide 69 by 4, that is 1 time, 4, then you write 29 times, then 7 times 28, the remainder is 1. Since I power, this is minus 1869, just you write this minus means minus you write, then this last number, last 2 divided by 4, the remainder is 1, you can write I power minus 1, which is equal to I power 0 is 1, then minus I power minus 1 can minus 1 by I. By I. That already I told 1. See, this is minus 1 by I. Already I told 1 by I value is equal to minus I. Therefore, this is 1 by I. Minus I means minus of minus plus. Therefore, you can write 1 plus I. This value equal to 1 plus I. Now, here you can take this summation n ranges from 1 to 12 I power n. That means what? You have to add the powers of this I with some powers starting from 1 to 12. That is, you can say I power 1 plus I power 2 plus I power 3 plus etc. plus I power 12. Now, its value is also 0. We can say simply. How? See, already I told if it is starting with 1 and the last number is divisible by 4 or it is a multiple of 4 means definitely value will be 0. You will not find each and every term values. Directly can write 0. For example, say if I power 1, I power 2, I power 3, I power 4, 4 consecutive power 0. Then we start from I power 5, I power 6, I power 7, I power 8. Again these 4 consecutive powers become 0. Then again I power 9 plus I power 10 plus I power 11 plus I power 12. 4 consecutive powers will be 0. Therefore, the powers of I starting with 1 and ending with an multiple of 4, you need not find the value of each and every term. Directly can write as 0. Now listen here, this one. Next one, I power 59. You have to divide 59 by 4. That is 1 time 4, then 19. How many times? 4 times is 16, then 3, remainder is 3. Therefore, this we can write I cube, then plus 1 by I cube. This also I power 59 only. Now, I cube means this value is minus I, then plus 1 by minus I. Now, which is equal to minus I. This is minus 1 by A. Minus 1 by A means you are getting plus I. You are getting plus I. Its value is also equal to 0. Okay, now after that, let us see I power 1 into I square into I cube etc. into I power 2000. What will be this value? Can you guess what will be this value? Now you cannot, because see, if instead of this into you have plus I power 1 plus I power 2 plus I power 3 plus etc. plus I power 2000 means this starting with 1 and this last power is multiple of 4 means you can write directly 0, but here we cannot write. Now let us say what is its value. Instead of plus we have into. Therefore, using the properties of integers, we can say I power 1 plus 2 plus 3 plus etc. plus 2000. Which is equal to I power. The powers of I are the sum of first 2000 natural numbers. You know very well, the sum of first n natural numbers, summation k is equal to n into n plus 1 by 2. Here n equal to 2000, you can write 2000 into n plus 1 means 2001 by 2, you can say based on that one. Now you can write I power 2000 by 2 equal to 1000 into 2001. Now this can be written as I power 1000 whole power 2001. You know very well I power 1000. This I power this 1000 is a multiple of 4. Therefore, its value will be equal to 1 power 2001. Now what is 1 power 2001 is equal to 1. Therefore, its value will be equal to 1. Likewise, let us see the next problem. Sixth solution, that is summation n ranges from 1 to 10. It's I power n plus 50. I power n plus 50. Here also I have to take the values of n from 1 to 10. Therefore, let us take I power n plus n equal to first 1 plus 50 equal to 51. Then summation means plus I power. If you take n equal to 2, this will be 52. Then plus I power 53, n equal to 3 means plus I power 54 if n equal to 4. Likewise, you can say plus I power if n equal to 10, 10 plus 50 equal to how much? 60 you can say. But you now see here, this one. It is not starting with 1. If it is starting with 1, you can directly say the result equal to 0 because it is a multiple of 4. But here it is not starting with 1. Now how do you write this? I power 51, 50 means you first take the 4 consecutive powers. I power 51 plus I power 52 plus I power 53 plus I power 54. 4 consecutive powers of I means definitely it will be 0. Then plus the next term is I power 55 plus I power 56 plus I power 57 plus I power 58. These are also 4 consecutive powers. Therefore, this value also will be equal to 0. Next, the two values will be left out. I power 59 plus I power 60. You can consider. Now we have only two values. I power 59 means if you divide by this 59 by 4, the remainder will be 3. Therefore, you can write I cube plus. Now this is a multiple of 4. Therefore, its value will be equal to 1. We know the I cube equal to minus I plus 1. Therefore, its value equal to minus I plus 1. Or you want to write 1 minus I. Therefore, its value will be like this. Likewise, you have a few example sums that I have left for your practice. Therefore, try to do all those example sums which are given in your textbook. And if you have any doubt, you can calculate with me. Next class, we will see about the complex numbers. Thank you, children.